use pair production in calculation. Again, this is a little bit of particle physics mixed with quantum physics. So it's asking you to find the wavelength of a photon which undergoes pair production. So we're going to quickly recap what pair production is to produce a proton-antiproton pair. So just going off in the highlighter, but what's happening in pair production is a photon has so much energy that it ends up splitting into a pair of particle and antiparticle. In this specific case, a proton and an antiproton pair. An antiproton is signaled with a line on top of the P like this. Just a quick recap, what we know about particles and antiparticles is that they have the same rest energy or same rest mass, but they're actually oppositely charged, meaning the charge of an antiproton would be negative. Just a few useful facts you need to know. One of them is actually useful in this question. The one that is the rest energy fact, because it gives you the rest energy of one of the particles. So 931.5 here, mega electron volts. And that would be the same as the rest energy of an antiproton, according to what we just mentioned. So I mentioned a photon has enough energy to produce a proton and antiproton pair. That means that that photon has to have the combined energy of these two at least in order to produce these two. Now that's how we actually get our energy, and we want to find wavelength from that energy. To do that, we combine two equations in this question. Those are E equals hf, and because we don't know the frequency, we use the fact that frequency is actually the speed over the wavelength. Replacing frequency with speed over wavelength, we have E equals hc over wavelength, and making wavelength the subject of this equation, we can just swap around these two variables. And I'm just going to write out here because we're going to do the rest of the working out here. Wavelength is hc over energy. H is a constant given to you in an exam, it's Planck's constant, so I'm just going to write that out as a value of 6.63 times 10 to the power of minus 34. Sorry for my handwriting, by the way, I'm still getting used to this new whiteboard. C is the speed of light, because we know that photons travel at the speed of light. That's 3 times 10 to the power of 8. And we're dividing all of that by the combined energy of the proton and antiproton pair, because, well, I already mentioned why I don't want to mention it again. I'll mention it again. It's because they have to have this photon has to have at least the combined energy of these two to produce these two. But one thing to bear in mind is that this energy is given in mega electron volts, which we have to convert into joules before we can use it in calculation. If we multiply by 1,000,000 or 10 to the power of 6, that converts it to electron volts, and then we multiply by 1.6 times 10 to the minus 19 to convert it into joules. So we take both of these energies, we'll say 2 times 931.5. We multiply them by 10 to the 6 to convert them both into electron volts, and then multiply by 1.6 times 10 to the minus 19, sorry. I'm just going to quickly do that on my calculator, but that will give you the final answer. 3 times 10 to the power of 8, 2 times 931.5, to the power of 6, 1.6 times 10 to the power of minus 19, and that gives you 6.67 times 10 to the minus 16. As a rule of thumb, if it doesn't tell you in a question, try to always round to 3 significant figures in A-level physics. But that's the final answer to this question. Hopefully that made sense, and if you have any questions, just let me know in the comments. Thanks for watching. And please subscribe if that helped. I'll upload regular videos like this at least once a day, if not twice a day.